One quick note I want to make about the last video is that we showed that it was a projection, that v star v was a projection, but more specifically it was onto the initial space of v. And this follows directly from the fact that the f that we had chosen here was orthogonal to the kernel of v, and it was arbitrary, which means that it was true for all of them, which means that here v star v f equals f gives us that it is in fact onto the initial space of v. Just a quick note before we move on. Wanted that for the sake of clarity. The book doesn't acknowledge that, but I think it's important to quickly note that. So, now, we assume v star v is a projection. And we take f to be orthogonal to the kernel of v star v. Then v star v of f equals f by definition. Hence, we get the follows. We get that the norm of vf squared equal to, we use our identity again, and we note that this by here is just the norm squared of f, right? So, this gives us that v preserves the norm on the kernel of v star v. Sorry, not the kernel of v star v, the orthogonal complement of the kernel of v star v. Here. Now, if v star v of f is equal to 0, then 0 equals v star vf, which would just be 0, f, but again this is the same thing as vf norm squared, which implies that vf equals 0. So their kernels are the same. V of f, the kernel of v star v is equal to the kernel of v, which implies that v is a partial isometry, which gives us the correspondence between 1 and 4, that they are equivalent. Okay. Now because of the symmetry of the problem, we can claim that simply by reversing the roles of v and v star, we get 2 implies 3 and 3 implies 2. And that again just follows from the symmetry of the problem and the fact that we can the fact that they that their roles can in fact be reversed. Now, since V star V is equal to V, if we assume V star V to be a projection. Now, this is because that V star V is onto the range of V by our above argument, and hence, since 4 implies 1, V is an isometry, so V of F equals F. So whatever this guy spits out, because it's in the range of V, V onto that is just going to give you the same thing. However, this guy is a projection, so whatever I plug in here, it is going to give me something, and it's going to give me the same element but in the range of V, or 0. So this thing is going to behave nicely because it's either going to send the kernel to the kernel of V, or it's going to send something to itself and then V sends it to itself again. So because of this, we get that V star squared is equal to V star V star by associativity, which is just going to be V star. So we get that V star is a projection. More specifically, onto the range of V as desired. And this last bit gives us the equivalence of everything. And this gives us everything because it gives us that 4 implies 3, linking the two pairs of equivalencies, and then again by reversing the positions of V and V star, we can get the reverse statement to be shown.